All right, let's talk about increasing and decreasing functions and the first derivative test today. So, definition of an increasing and a decreasing function. A function is f is increasing on an open interval when for any two numbers x1 and x2 in the interval, x1 is less than x2, implies that f of x1 is less than f of x2. All right, what does that mean? If you look at that on a graph, okay, and here's x1, and it's less than x2, and here's f of x1, and here's f of x2. All right, and f of x2 is less than f of x1. I'm sorry, f of x1 is less than f of x2. So it doesn't really matter what this does in between here. It can go like this. It doesn't matter. But this is an increasing function. It's getting bigger. Okay? Now I look at a function that is decreasing. A function f is decreasing on an open interval when for any two numbers x1 and x2 in an interval. So again, we're starting with the graph here. Here's x1. It's less than x2. Let's see. In the interval, when any two numbers x1 and x2 in the interval where x1 is less than x2 implies that f of x1 is less than f of x, or is greater than f of x2. So here's f of x1, and here's f of x2. Doesn't matter what the curve does in between there, but that's a decreasing function. Theorem. Let f be a function that is continuous on the closed interval ab and differentiable on the open interval ab. If f prime of x is greater than 0, so if the slope is greater than 0 for all x in ab, then f is increasing on the interval ab, a to b. If f prime of x is less than 0, or if the slope is less than 0 in ab, then f is decreasing on the interval a to b. And if f prime of x is 0, so essentially the slope is 0 for all x in ab, then f is constant on ab. All right, so if you think of the derivative here in terms of it's the slope, then this makes perfect sense. If the slope is bigger than 0, it's an increasing function. If the slope is less than 0, it's a decreasing function. And if the slope is equal to 0, that is a constant function. Okay, find the open intervals on which f of x equals x cubed minus 3 halves x squared is increasing or decreasing. Okay, so the first thing we're going to do is take the derivative. So f prime of x is going to be 3x squared minus 3x. There's the derivative. Now, the next thing you want to do is you want to set this thing equal to 0. Okay? We want to find where is this thing 0. All right, so if I take this, I can factor out a 3x. That leaves me with an x minus 1 equals 0. So I got two numbers that I'm multiplying together to equal 0. That means one of these two numbers has to be 0, so x either has to be 0 or x has to be 1. Okay, now what we're going to do is we're going to region test this thing. Okay, so I've taken my graph, and I've got 2 points where the slope is 0. So that tells me that this graph is going to look something like this. Okay, it's got a slope of 0 here, it's got a slope of 0 here. So what that means is I've broken this thing into 3 regions. I've got a region where over here, I've got a region in between here, and I've got another region over here. And I'm going to region test the thing. So I'm going to find out what the slope is doing in any one of those 3 regions. Okay, so it doesn't matter what point that I pick, I just have to pick a point. All right, so I'll pick something easy. I'm going to find f prime of -1. And I'll probably I have to find a point. This is, by the way, this graph isn't exactly correct because this right here is 0, right? So this is 0 and this is 1. So I picked a point out here, -1. I'm going to pick a point in between here. So I don't know, 1/2 would probably be the easiest one, f prime of 1/2. And then f prime of something bigger than 1, something easy like 2. And I'm going to find out what's the slopes there. So if I plug in f prime of -1, I get 3 times -1 squared minus 3 times -1. So that's going to be 1 times 3 is 3. And the negatives cancel out. That's plus 3. So the slope is 6 at -1. Now that's greater than 0. So this tells me that this is increasing over here. Slope is increasing. Which kind of matches my picture, right? So then I'm going to try 1/2. Okay, so f prime of 1/2 would be 3 times 1/2 squared minus 3 times 1/2. So this is what, 3/4? Because that's 1/2 squared is 1/4 times 3 is 3/4. Minus 3/2. I think that's what, -3/4. That tells me it's decreasing because the slope's negative, which also matches my picture. Okay, let's try f of 2 or f prime of 2. So 3 times 2 squared minus 3 times 2. That's 4 times 3 is 12 minus 6, which is 6, which tells me it's increasing. Okay, so I'm done with that problem. Find the open intervals. So I haven't written the intervals yet. So the open intervals are that it is increasing on the interval -infinity to -1. And it's also increasing on the interval 2 to infinity. It is decreasing on the interval from 0 to 1. Okay, this is actually my answer right here. All right, so what did I do? I find the slope, and I determine, is the slope increasing or decreasing? Now, I have to figure out there's going to be multiple places where I need to test it. I find those places by finding when's the slope 0, because the slope being 0 is when it changes from going to be a positive slope to a negative slope, or from being a negative slope to a positive slope. Okay, so I find those points. It gives me, in this case, I had 2 points. That gives me 3 regions, one over here, one in the middle, one over here. I test points, numbers in those regions, and I determine, is the slope positive or negative? Okay, if it's positive, it's increasing. If it's negative, it's decreasing. And then I make sure to write those regions down. Okay, so, or the intervals. Make sure you use interval notation, please. Okay, so guidelines for finding intervals on which a function is increasing or decreasing. Let f be continuous on the interval AB. To find the open intervals on which f is increasing or decreasing, use the following steps. Locate the critical numbers of f in AB and use these numbers to determine test intervals. Okay, what are critical numbers? That's when the derivative is 0. Determine the sign of f prime of x at one test value in each of the intervals. So when we went back here, we calculated the actual slopes. We didn't really need to do that. All we need to do is determine, are they positive or negative? I don't really care what they are. because depending on what answer I choose, I mean, I chose -1. If you chose -2, you're going to get a different answer for the slope, but it's still going to be the same sign. So, it would still be increasing or decreasing. Use the previous theorem to determine whether f is increasing or decreasing on each interval. These guidelines are also valid when the interval AB is replaced by any of these intervals, -infinity to b, a to infinity, or -infinity to positive infinity. If a function is strictly monotonic on an interval, when it is either increasing on a function is strictly monotonic on an interval when it is either increasing on the entire interval or decreasing on the entire interval. The first derivative test. Let C be a critical number of a function f that is continuous on an open interval I containing the point C. If f is differentiable on the interval except possibly at C, then f of C can be classified as follows. If f prime of x changes from negative to positive at C, then f has a relative minimum at C, f of C. Okay, what does that mean? That means if my derivative here is negative and then it changes to positive, that means that I've got a minimum in that situation. If f prime of x changes from positive, so here I have a positive slope, here I have a negative slope, so it changes from positive to negative, that means I got a maximum in there somewhere at CF of C. If f prime is positive on both sides of C or negative on both sides of C, then f of C is neither a relative minimum or a relative maximum. What would that look like? That might look like a graph something like this, where you have something that goes like this. And I had a critical point right here where the slope is 0, but the slope is positive here and the slope is positive over here. Find the relative extrema of f of x equals 1/2 x minus sine x on the interval from 0 to 2 pi. Okay, so here's a nice little graph. We can compare our answer to the graph. So again, first thing I do is I take f prime of x. It's going to be 1/2. Derivative of sine is cosine, so that's minus cosine x. Okay, and I set that equal to 0. So I got to find the critical points. So I can move the cosine over here, in which case I get cosine of x is 1/2. And so x is the arc cosine of 1/2. And so that gives me pi over 3 and 5 pi over 3. Those are my critical points. And you know what? It matches up with my picture. Here's pi over 3 right here. And here's 5 pi over 3 right here. Now, it gives me 3 regions to test. I have a region right here from 0 to pi over 3. I have another region from pi over 3 to 5 pi over 3. And I've got a region from 5 pi over 3 to 2 pi. I have to test all those. So I got to find something in between there. So let's find something easy. Like let's find f prime of pi over 6. Okay, that should be right here. All right, so that would be 1/2 minus the cosine of pi over 6. All right, cosine of pi over 6 is going to be square root of 3 over 2. And I believe that's negative, so yeah, that's negative. I don't even care if it's positive or negative, or I don't care what the number is. It's negative. That tells me that it's decreasing. And that goes with this picture, doesn't it? The slope is decreasing down to here. All right, now I'm going to find a place in between pi over 3 and 5 pi over 3. I don't know. Let's try f prime of pi. So it'd be 1/2 minus cosine of pi. So the cosine of pi is going to be -1. So this is 1/2 minus -1, which is 3/2, which is positive. So that means it's increasing, which makes sense because it's increasing from pi over 3 to 5 pi over 3. This thing's getting bigger that entire time. All right, how about 11 pi over 6? So f prime of 11 pi over 6 is going to be 1/2 minus cosine of 11 pi over 6. So that's going to be 1/2 minus cosine of 11 pi over 6 is square root of 3 over 2 again. So again, that's negative, so that's decreasing. All right, so what are my intervals? My actual answer to this is it is increasing from pi over 3 to 5 pi over 3. It is decreasing from 0 to pi over 3 and from 5 pi over 3 to 2 pi. Find the relative extrema of x squared minus 4 to the 2/3 power. Okay. So, I got to take the derivative. So, f prime of x is going to be 2/3 x squared minus 4 to the -1/3. I got to use the chain rule times the derivative of the inside, which is just 2x. All right, so I can rewrite this. Let's see, in my numerator, I've got 2 times 2x is going to be 4x. The denominator, I'm going to have 3, and I'm going to have the cube root of x squared minus 4. All right, so let's set that equal to 0 so I can find the extrema. Okay. If I plug, okay, so it's going to be 0 in the numerator, 0. And since I have a cube root down, okay, so if I plug in 0, I get 0 on the top. I got to be careful at the bottom because I've got this root, but it's a cube root, so if I put a 0 in here, I get a cube root of -4, which is some number I can do. It's no problem. So x is going to be 0. That is going to be one of my critical points. Okay, my other critical points are going to come from the denominator, and that's when the denominator is going to be 0, and I'm going to be undefined at those points. So, like if I plug in plus or minus 2 here, I'm going to get 4 minus 4, which is going to be 0. The cube root of 0 is 0 times 3 is 0. So I'm going to have other critical points at 2 and -2. And you can see from the graph, here's the graph, I definitely have a critical point right here, I have one right here, and I've got one right there. The slope is 0. So, now I need to determine, okay, those are going to be my critical points. If I actually want to find the critical point, I need to take these x's and plug them back into the original f of x to find out what the y is, because I would actually be finding this point, and that point right there. So f of 0 is going to be 0 squared minus 4 to the 2/3, which is going to be negative 4 to the 2/3, which is going to be the cube root of 16. Whoops, not the 16th root of 3, the cube root of 16. Which matches up with right here. F of negative 2. So if I plug that in, I'm going to get negative 2 squared minus 4 to the 2/3 is going to be 4 minus 4 to the 2/3, which is 0. And then F of 2 is going to be 2 squared minus 4 to the 2/3, which is also going to be 0. And so I have extrema at 0 cube root of 16, and at negative 2, 0, and at 2, 0. Now, what I'd really like to know is, are those minimums or maximums? Now, if you have the graph, you can just look at the graph and tell. However, if you don't have a graph, you can tell by region testing this thing. So what you would do is, these are your critical points. I would pick a point smaller than negative 2, so like negative 3, and I would figure out what the slope is. So F prime of negative 3 would be, and all I need to do is determine, is that going to be positive or negative? So it's going to be 4, whoa. That's going to be 4 times negative 3 over 3 times the cube root of 9 minus 4. Okay, so this is a negative on top, and this is going to be a positive number on the bottom, so that's going to be negative. Okay, so that tells me it's decreasing. Okay, then I would test the next region. So something, I've got to test something between negative 2 and 0, so negative 1. F prime of negative 1 would be 4 times negative 1 over 3 times the cube root of negative 1 squared is 1 minus 4. So this is going to be a negative on top, and it's going to also be a negative on the bottom because this is going to be negative. So that's going to be a positive, which means it's increasing. Now I got to do the same thing on the other side. So I'm going to test 1 and I'm going to test 3. So F prime of 1 would be 4 times 1 over 3 times the cube root of 1 minus 4. So this is going to be negative, that's going to be positive, this whole thing is going to be negative, so it's decreasing again. And then F prime of 3, 4 times 3 over 3 times the cube root of 9 minus 4. That's a positive over a positive, which is a positive, so it's increasing. Okay. Now, here it goes from negative slope to a positive slope. So that tells me that between these 2 points, that's a minimum. Okay, so if I look here, that's this region and this region, that's definitely a minimum. Next, I would test those 2 points. Okay, my slope goes from positive to negative, so that tells me this is a maximum. Then I would test this. It goes from a negative slope to a positive slope. That's again a minimum. And that totally matches up with the graph. So I got a min, I got a max, and I got another min. And I don't even have to have the graph. I can figure that all out without the graph. Okay, find the relative extrema of f of x equals x to the fourth plus 1 over x squared. So I'm going to take this thing and rewrite it. See, x to the fourth divided by x squared is just x squared plus 1 over x squared, which I'm going to rewrite again as x squared plus x to the negative 2 power. All right, so I can take the derivative of this. So that's going to be 2x minus 2x to the negative 3. So this becomes 2x minus 2 over x cubed. I think I'm going to get a common denominator on this too, so I can get this all over the same thing. So I'm going to multiply this by x cubed over x cubed. And I'm going to get 2x to the fourth minus 2 over x cubed, like that. I think that'll be the easiest thing to work with. All right, let's set it equal to 0 and find out what the critical points are. So when the numerator is 0, so 2x to the fourth minus 2 is 0. I can factor out that 2. Divide by 2. I can factor this down to x squared plus 1 times x squared minus 1. And then I can factor that down. That's the difference of two perfect squares also. So this is it's going to be x squared plus 1 times x minus 1, x plus 1. This is never going to be 0. This is going to be 0 at 1. This is going to be 0 at negative 1. So I get 2 critical points there. I also get a critical point out of the denominator because this cannot be 0, so there's a critical point at 0. So these are my critical points. All right. Now, what am I going to do with those critical points? Well, I know that maximums and minimums occur there. So what am I supposed to do? Find the relative extrema. Okay, so I can take these critical points and plug them into the original function to find out what the points are. So if I plug in, oops, not what I wanted to do. There we go. F of 0, well, I can't plug 0 into here because that's undefined. So this is undefined, and that tells me that there is a vertical asymptote there. Okay, so I don't have an answer. I can find f of negative 1. So that'd be negative 1 to the fourth plus 1 over negative 1 squared. So that's going to be 1 plus 1 is 2 divided by 1, so that's 2. And f of 1 is going to be 1 to the fourth plus 1 over 1 squared is also going to be 2. So I've got 2 points that I'm going to deal with here. I've got the point negative 1, 2, and I've got the point 1, 2. Those are where my extrema occur. All right, now I just need to figure out, are they maximums or minimums? So I could region test from my critical points, f prime of x. Okay, so, you know, I could take -2. I could find f prime of -2. I need something between 1 and 0, or -1 and 0. So that's going to be f prime of -1/2. That didn't come out very well. I'm also going to find f prime of 1/2, and I'm going to find f prime of 2. And remember, all I got to do is find out, are these things positive or negative? So my equation is 2x to the 4th minus 2 over x cubed. Actually, it might be easier to do 2x minus 2 over x cubed. It's the same thing. Okay, so this would be -4 minus 2 over -2 cubed. All right, that's a negative. That's also, let's see. This is going to be, this negative is, okay, so this is going to be -4 minus 2 over -8. So that's -1/4. So those cancel out. And I end up with -3.75. So this is negative. So it's decreasing. And then 2 times -1/2 minus 2 over -1/2 cubed. All right, so that's going to be -1. And again, the two negatives are going to end up canceling out in the end. This is going to be 2 over 1/8. So that's going to be 16. This is definitely positive. It's increasing. I can do the other two the same way. I'm going to find out it's decreasing and increasing. So since this slope ends up going from decreasing to increasing, this is a minimum. Okay, the same thing will occur between these two. You'll have another minimum. And you can't do it between these two because it's discontinuous between here. So if you look here, there's a vertical asymptote right here. That means it's discontinuous. So there's not going to be a minimum or a maximum along there because there's an asymptote. The path of a projectile. I'm going to let you take a look at this kind of on your own. We're not going to do this today because I've already thrown a lot at you. Here's your assignment that you're going to do. Take a look at that, and then we'll get back together, and we'll see you next week.